Hello everyone, my name is TV Kumar. I'm from Sri Venkateshwara College of Engineering. Today I'll be discussing about statistical methods and what are its uses in real life. So this is the content of today's presentation. Introduction to statistical methods, statistical models, curve fittings, algebraic fittings of function to data points, correlation and regression, types of correlations, coefficient of correlations, importance of a line, importance of statistics, and statistics in daily life. In this slide, we'll be learning what are statistical methods. Statistical methods are the tool that help you to analyze a set of data. Experts use statistical methods as a part of statistical analysis, which are gathering of and interpreting quantitative data. Using a statistical model can help you evaluate the characteristics of a sample size within a given population and apply your findings to the larger group. While statistics and data analytics may be statistical models are more than others, many can benefit from understanding statistical models, including marketing representatives, business executives, and government officials. In this slide, we'll be looking into some of the statistical models. These are mean, standard deviation, hypothesis testing, regression, sample size determination, analysis of variance. In this slide, we'll be looking into what is a curve fitting. A curve fitting is the process of constructing a curve or a mathematical function that has the best fit to a possible series of data points, possible subject to constraints. Here we see an example of a curve fitting graph which is shown in this image. In this slide, we'll be learning about the algebraic fittings of a function to a data points. There are three types in this. These are fitting lines, fitting polynomial curve, and geometric curve. So let's start with the fitting lines. So, straight line is basically represented by the equation y is equal to x plus b. The first degree polynomial equation is a line with a slope a. A line will connect any 2 points, so the first degree polynomial equation is an exact fit through any 2 points with distance x coordinate. Here are the equations for this fitting lines for straight line. Sigma yi is equal to a sigma xi plus bn. So moving on to the next one, fitting polynomial curve. If the order of the equation is increased to second degree polynomial, the equation results as y is equal to ax square plus bx plus c. So here are some equations for the fitting polynomial curve. Sigma yi is equal to axi square plus bxi plus nc. Sigma xiy is equal to a xi cube plus b sigma xi plus c sigma xi. So moving on to the last one, we have the geometric curve. The geometric curve is represented by the equation y is equal to x plus b, and these are the equations used to solve a geometric curve. Sigma yi is equal to n a plus b sigma I, and y I is equal to a sigma I plus b sigma I. In this learn, we'll be learning about correlation and regression. The word correlation is used in everyday life to denote some form of association. We might say that we have noticed the correlation between foggy days and attacking of freezing. However, statistical terms we use correlation to denote association between two quantitative variables. We also assume the association is linear, that one variable increases or decreases a fixed amount per unit increases or decreases in the other. The other technique that is often used in these circumstances is regression, which involves estimating the best straight line to summarize the association. In this slide, we'll be looking into the types of correlation. There are two types, positive correlation and negative correlation. So what is positive correlation? If any increase or decrease in the value of one variable correspond to the increase or decrease of the other, it is called positive correlation. The few examples for these are height and weight, rainfall and yield of crops. Negative correlation. In an increase or decrease in one corresponds with a decrease or increase on the other hand. So examples for this is increase in price of material and decrease in the demand. So moving on to the next slide, coefficient of correlation. The degree of association is measured by a correlation coefficient denoted by R. It is sometimes called Pearson's correlation coefficient after its originator and is a measure of linear association. If a curved line is needed to express the relationship, other or more complicated measures of correlations must be used. The correlation coefficient is measured on a scale that varies from +1 through 0 to -1. The formula for coefficient of correlation is R is equal to sigma x minus x bar into y minus y bar by n into sigma x into sigma y. So let's see what these terms mean. X bar means the mean of x, y bar is the mean of y, sigma x is the standard deviation of x, and sigma y is the standard deviation of y, and n is the number of values given in the equation. In this slide, we'll be learning about the regression of a line. A regression of a line indicates a linear relationship between the dependent variable on the y-axis and the independent variable on the x-axis. Here in this slide, we'll be looking into some of the equations for line of regression. Line on regression of x on y. X into x bar is equal to r into sigma x by sigma y into y minus y bar. So for the equation for line of regression on y on x is y into y bar is equal to r into sigma y by sigma x into x bar. So the equation for coefficient of regression is r is equal to plus or minus root of coefficient of x into coefficient of y. So let's look into some of the daily life applications of statistics. It is used in weather forecasting, sales tracking, health insurance. In weather forecasting, statistics is used heavily in the field of weather forecasting. Forecasters will regularly say the things like there's 90% chance of rain today between 5 p.m. to indicate that there is a high likelihood of rain during certain hours. In sales tracking, retail companies often use descriptive statistics like the mean, median, mode, standard deviation, and many other things to predict the sale behavior of certain products. In health insurance, companies often use statistics and probability to determine how likely it is that certain individuals will spend a certain amount of on healthcare each year. Or it is used in traffic and medical studies as well. In traffic engineers regularly use statistics to monitor the total traffic in different areas of a city, which allows them to decide whether or not they should add or remove roads for optimized traffic flow. Also, traffic engineers often use time series analysis to monitor how traffic changes throughout the day so they can optimize the behavior of traffic light. In medical studies, statistics is regularly used in medical studies to understand how different factors are related. Medical professions often use correlation to analyze how factors like weight, height, smoking habits, exercise habits, and diets are related. Why are statistics methods important? For designing effective surveys for customers or employees, to create experimental studies such as study to test a new product in development, for assessing the value of potential investment, or even to conduct specific scientific experiments. Thank you everyone for watching this video. I hope you have a great day.